recently discovered that we could be sucked into a super-duper massive black hole. The things you're about to find out will greatly expand your awareness of the cosmos. A new study by Russian researchers Nikolai Gorkovy and Sergei Tulbashev truly shocked the scientific community, since it's so far removed from the standard cosmological model of a single universe. These two astrophysicists have suggested that our universe undergoes countless expansion and contraction cycles, with a novel theory for what is generally called the cyclic or oscillating model. Think lots of big bangs and big crunches. People far from physics and astronomy will think,
well, if I got shrunk down, I'd probably notice that.
The process is a bit difficult to explain, but I'll help you make sense of it all. Because, as it turns out, we can actually witness the next contraction or crunch. These scientists also referred to the possibility of a super-duper massive black hole forming that will eventually consume our entire universe, and that means together with us inside it. In this video, you'll find out what will happen to you when the universe starts shrinking. Why might all the black holes merge into one? And most importantly, you'll get insight into the answer to the controversial question, can black holes consume the universe? How black holes affect the universe. We are often confounded by the fact that just 5% of the Earth's oceans have been explored, but it's nothing compared to what we know, or rather don't know, about dark matter and dark energy. Knowledge of the processes involved with supermassive black holes was enhanced when Gorkovy and Tulbashev took up the issue. These days, there are thought to be as many supermassive black holes as there are large galaxies in the universe, around 2 trillion, with one big black hole at the center of most of them. But exploring them is obviously difficult and problematic. Modern physics knows that 85% of our universe's mass is something unknown, what we call dark matter. And most of the energy is, if you can believe it, also something unknown. Basically, we simply have very little idea of what 95% of our universe is made of. At this point, all we know for sure about dark matter is that it serves as the glue holding together galaxies with its gravitational heft. That's how we discovered it, in fact, because when we look at galaxies, there just isn't enough visible matter, meaning star systems, to hold them together. And what we call dark energy is, we surmise, a mysterious force pushing the universe apart faster and faster everywhere. This situation is so dire that some physicists, out of desperation, have suggested adjusting the law of gravitation at large scales to fit the observations, so that we can exclude dark matter somehow. So, the news that the gain and loss of black holes' mass might be involved with the shrinking of the universe caused somewhat of a hubbub in cosmology circles.
Oh my God.
Most physicists had never thought about such things before. The Hubble Space Telescope has observed a distancing, a moving away of near-Earth objects and stars on the outskirts of our galaxy. With the Hubble's help, we discovered that the universe is expanding at a rate of 74.03 plus or minus 1.42 kilometers per second per megaparsec. So far, for some of you, these are just weird, incomprehensible numbers, but soon everything will make sense. Stay with me. The thing is that observations from another space telescope called the Planck, which monitors cosmic microwave background radiation, or CMB, gives us completely different data, only 67.66 plus or minus 0.42 kilometers per second per megaparsec of space. The Planck basically looks at things further away, and that means older, further back in time. So it turns out that the rate of expansion of the universe away from us is lower than it is in close proximity. But in fact, if the expansion of the universe was caused by mass loss in the past, then in the very distant past the rate of expansion would clearly be different from the one we see today. But still, what's going on with dark energy? Why is it more powerful in areas closer to us than it is billions of light years away from our galaxy? And even more questionable is the astronomical revolution regarding gravitational waves that took place in 2016. The American Gravitational Wave Detector, called LIGO, received dozens of signals of different statistical significance, more than a dozen of which had a very high credibility level. And almost all of them are gravitational waves caused by the merger of two black holes. So where did so many black holes come from? Evidently, there must be some unexpected source for these formations. Researchers have suggested what might serve as such a source, and it's a Phoenix universe. According to this idea, the existing universe underwent many cycles of contraction and expansion. Our cycle is not the first, and most likely not the 100th. It's just one of countless cycles, like many that came before and many that will come after. In the first phase of each cycle, our universe expands, and that's what's happening now. It reaches a peak size, and then in the second phase, it begins to shrink. With this compression or contraction, the distance between black holes gets steadily reduced. And in the final phase of the shrinking cycle, the diameter of the universe becomes not 93 billion light years as it is now, but only about 10 light years. As the black holes merge into one another, their number will be cut in half. Then the total mass of the universe will be reduced by around 5% as the mass is converted to massless gravitational waves. And the remaining black holes can continue merging into one another, and the mass of the universe will continue to be reduced by 5% again and again. Having reached contraction to about 10 light years, with a temperature now 10 billion Kelvin from compression of the CMB, all the atoms of heavy elements decay. Concurrently, the merger of black holes transforms most mass into gravitational waves, and when this transformation reaches a critical threshold, the contraction of the universe stops, and it starts expanding rapidly. This moment in the model of Tulbashev and Gorkavi is interpreted as the Big Bang, the beginning of the next development cycle of the Phoenix universe. You might ask, if our universe is in the process of expanding now, then how can our expanding universe start shrinking? Well, when black holes collide, as mentioned, they emit gravitational waves, contraction. The evolution of the Phoenix universe bears a resemblance to the work of a colossal pendulum. As the pendulum swings up, its kinetic energy transforms into potential energy, and the upward velocity gradually decreases, finally hitting a peak, and then the pendulum swings down again. The universe, as it expands, will turn the energy of gravitational waves into mass until there's so much mass that the expansion is replaced by contraction. But for this process to take place, the universe needs the intervention of dark matter. Will we be able to observe it? Probably. Passing between the Earth and a star from another galaxy, dark globular clusters of dark matter are likely to create a gravitational lens effect, which we could observe. There's a chance that it will be easy to distinguish from other areas of the sky, but this isn't definite. So, will we know when we've entered a black hole? We've already figured out that if something consumes our entire universe, it wouldn't be one hole, it would be the merger of countless black holes. We're often intimidated by the idea that if we enter a black hole, we'll get stretched out like spaghetti, as our feet, for example, get pulled faster than our head if we enter feet first. But that's not necessarily so. Falling into a black hole will make us face spaghettification and death only if the hole is small. We'll be consumed by something mega, uber, super gigantic. With a supermassive black hole, the difference between the effect of tidal forces on your head and your feet will be insignificant. Most likely, entering such an object will be not only painless, but also imperceptible for most of us. Just like you didn't notice that the summer just went by and you didn't have any fun. Astronomers will follow this process carefully. They'll see redshift in distant galaxies gradually fading away. This would mean that the edge of the main black hole is approaching. Then everything will suddenly change to a blue color. The universe will go from expanding to contracting. Actually, that would be the ultimate sign that we've been consumed by a black hole. So that's it. You won't have to go to the back of the bookcase like in Interstellar. This fact should make you happy. But let's admit that such a boring and low-key apocalypse is perhaps mildly disappointing.
Boring!
I mean, if we're supposed to die, it should be spectacular. Let me give you a more detailed description of what the shrinking universe doomsday will look like. Let's start with what we need for the real end of the world. The hypothesis of Gurkhavi and Tulbashev reveals that somewhere in the universe, there's a huge black hole, far more massive than any of the already discovered supermassive black holes. Let's assume it appears and eventually consumes the entire universe, including, of course, the Earth and all of us. It won't be a fleeting moment. Have you ever woken up at night because you heard a strange, sharp sound from the kitchen and then realized it was just a plastic water bottle you compressed for recycling, expanding back to its original form? It's something like that, but it will take billions of years, not just a few seconds, to shrink the universe. And for the expansion to stop, according to estimates made by Gurkhavi, it will take 10 to 20 billion years from now. The reverse compression or contraction may take 29 to 30 billion more years, but the end will come eventually. First, the night sky will become so hot that every living creature will die on the surfaces of all the planets. Then it will become even hotter. The temperature will reach 100 billion degrees, and that's when the universe is rapidly shrinking. We won't be able to survive the Phoenix universe contraction cycle. There may be a way out of this situation, but no one knows what it is yet. But you, yes, you who are watching this video right now, are unlikely to witness these events. So, Armageddon will be the concern of our distant descendants, if they make it to such distant times, which of course is not assured by any means. There's only one person who will manage to see it, Jared Leto, because apparently this guy never gets old and will live forever. If the universe can be a phoenix, can we also? This study by Gurkhavi and Tulbashev is simply mind-blowing. It's hard enough for us even to conceptualize how long ago the advent of our universe took place. But if our universe is not a one-time thing, but contracts and expands repeatedly, maybe this isn't the first time we've been here. That we, you and I, have existed. So of course, let me know in the comments if you've ever experienced deja vu.